Hey everyone, this is a review of the Anycubic Kobra Max. This is a massive 3D printer that's going to let you print just about anything that you want to. So I'm going to briefly cover setup, I'm going to cover print quality, any tuning steps that I did with this, and then show you an idea of how this thing performs. So to start off with, assembly is super easy with this thing. It comes really packaged well in custom cut foam, and really you just have to put the top frame on here. Everything else is already assembled, and then put the stabilizing braces on, and that's just about it, other than plugging in some cables. The build volume on this thing is absolutely massive at 400 by 400 millimeters square at the base and 450 millimeters tall. That's one of the biggest print volumes that you're going to find on this quality level of printer. Because this has such a large build volume, it's also got a massive footprint. For actually setting it on a workbench, you really only need 24 inches by 24 inches square for everything to rest on. But since this is a bed slinger and since it's got the filament way out here to the side, you pretty much need 3 feet square of operational volume clear to use this. So that's 36 inches by 36 inches. This thing can print pretty fast too. I've pushed it up to 180 millimeters per second for PLA, and it seemed to handle it just fine. Now with such a large build volume and being able to do such heavy prints, having a bed slinger like this requires a lot of stability. So you can see there are dual Y-axis rails, and underneath here there are 12 rollers supporting this platform. So it's got plenty of structure to keep it from warping or tilting or anything like that. It is plenty powerful. The single stepper motor in the back here drives both of these with a belt, and it does a great job having enough power to move it back and forth, even with heavy prints on here. You've also got dual Z-axis lead screws on both sides of the platform, so it's going to keep it level and you don't have to worry about one side drooping. One really nice thing about all the belts on this is you've got a tensioner right here, right on this. So if you're having belt looseness problems, you don't have to get out some tools, you don't have to do anything, you just screw this in here. They've also got one for the Y-axis. So up top here, you've got a filament runout sensor, which I think is absolutely necessary for a printer this large, because if you use up a whole roll of filament, this will stop your print when the filament isn't any more in between here, and it will pause and let you load new filament and continue printing without having a failed print. You have a Bowden style extruder right here that feeds through the tube into the hot end. I really haven't had much issues with the printer at all. The only problem I've had with this is the gear on this that drives the filament came loose on the shaft, and it has a set screw that I just tightened back down, and I haven't had any problems since. So that was after like 150 hours of printing that happened, and it just wasn't extruding. And I opened this up, tighten that set screw down. If it does come loose again, I'll probably open it up and put some Loctite on it and be done with the issue. This has a glass bed that is held on by 6 clips. I've had good results with this in its auto leveling routine. It comes and hits 25 points. It's just got a little strain gauge in the nozzle, and it comes down and touches the nozzle in each of those spots and builds a mesh of how to keep it level when it's doing a print. It does a great job. Now you'd think a bed this large might be hard to heat evenly, but I haven't had any problems with layers peeling up over the whole distance. And so it gets up to heat pretty quickly as far as I'm concerned. A few tips that will help with any 3D printer: just use a glue stick for better bed adhesion. And check all of these rollers for looseness. They shouldn't be able to turn unless they move what they're supporting. And if they're too loose, you can tighten the eccentric nut. The power switch is over here on the side. Just turn it on. Then down here in the front are all your controls. You can put a micro SD card in here to load your prints. You can also connect with a USB cable. And then you've got a touchscreen interface over here. So when you're ready to print, you just come over here and hit print. You can pick whatever file you want. It's a G-code file loaded on here, and tell it to print. You can prepare, you can level the bed, preheat, and then you can load and unload filament. As far as tools go, you can move your axis, set your temperature, adjust your speed. It's got a light on the print head that you can turn on and off, and then this just disables the motor so you can move the axes any way you want without having the motors fight you. One thing they don't have the ability on here is to change your E-steps, which I was a little bit surprised about. So that's a technical thing where you can calibrate your prints. You can print a 20 millimeter by 20 millimeter calibration cube and then measure it with calipers and see how big it is. This one was actually 1.5% undersized in the X and Y direction, and it was about 1% oversized in the Z direction. So If you want to change your E-steps, you got to connect with a USB and do it through G-code, which is a little more complicated. It might be difficult for first-time users. Or what you can do is you just go into your slicer and you scale your settings a little bit by that percentage. And that's a lot easier to do. It's very user-friendly. And I usually don't even do that unless I need a perfectly accurate print, because within 1% is pretty good, honestly, to start with. So materials that I've personally run through this: TPU, PETG, and PLA in multiple different types. So for each of those types of filament that I've tried on here, I've got a very high quality PLA benchy. You can see it's got great detail on this, virtually no stringing. It did great with the overhangs, the bridging, just fantastic quality from this printer. This black one is in PETG, which is a little bit trickier to print than PLA, and this one came out great. I just took a stab at it using my Ender 3 settings and just translated them straight to this printer, and they came out fine. There's a little tiny bit of stringing you can see there in the cabin, but everything else is pretty much perfect. And finally, definitely the hardest filament to print on this printer that I've tried is TPU. A lot of people say you can't print TPU on a Bowden extruder like this one has, but I got it dialed in pretty well. This is actually the Filament Friday profile from Chuck Hellebeck that he's got shared online. It's great, except for it's got a few little blobs, and it might be due to his profile is for an Ender 3, and this one's got a slightly longer Bowden tube. So I messed around with mine, and the stringing is a little bit worse, and the overhangs aren't good on mine, but I don't get those same blobs that he was having nearly as extreme. So between these two, I've got two good profiles. If my model has overhangs, I use this one. If it doesn't have overhangs, I use this profile that prints a little bit faster. Now, don't use the stock profile for TPU that comes with the Anycubic Kobra, because this is what it turns out, which is just laughably bad. Stringing all over the place. Terrible, terrible overhangs. It's just not a good setting, at least for the Overture TPU that I'm using. Maybe it works better with a different brand of TPU. But with a little bit of tuning, you can get great results with much less stringing, even with a Bowden setup. All right, let's take a look at some of the things I printed with this. First of all, we've got a giant benchy in PLA. This thing is pretty rough quality because I was just trying to crank it out. I did this benchy in 3 hours with a 0.8mm nozzle and 0.6mm layer height. There's obviously some tweaking I could do to this to make it a higher quality print, but I'm just impressed that it printed something this big, this fast. And if you just need a functional part like this, this will be fine as far as the finish goes. If you want something higher quality, you've got to slow it down a little bit and do some extra skin layers. But overall, like, I'm so impressed that it can print this fast. The longest print I've done with this thing so far is this massive marble run. I found this online for the model and scaled it up 200%. It just barely fits on the bed this way. I used a spool and a half of this rainbow PLA, and it took 105 hours to print and had 0 issues the whole time. I am super impressed with the ability of this printer to move around such a heavy print on the bed without having really any errors at all. Absolutely the only small issue I had with this, there's a little bit of ringing or ghosting right around here on the interior of this funnel, and that is the only real flaw I found in this. Now, when you're doing massive prints like these two, you can change out to a 0.8mm nozzle that is included as a second nozzle with this machine. It comes with a 0.4mm installed. And when you do a 0.8mm nozzle, you can crank out a ton of material and do vase mode, which is basically it spiralizes and does one pass for each layer all the way up. And that's what both of these are printed in. They're a 0.6mm layer height, 0.8mm width. That is cranking out a ton of filament. I think I printed both of these at 45mm a second, which is a lot of filament coming out of that extruder, and the extruder had no problem keeping up. So this is a 16-inch tall print. It's absolutely massive. We needed a trash can for my daughter's room that fit behind a bookshelf, and they don't really make them that narrow, and so I just made one and printed it. This one took less than 8 hours to print. This one took around 5, I think. But overall, like, both of these are just a ton of filament laid down in a very short amount of time, and it did it with a great quality. It's got a volcano style hot end, which means your nozzles are a lot longer. This is the Anycubic Kobra nozzle. This is an Ender 3 nozzle. You can see how much longer distance you have to heat up that filament while it's in the nozzle. Also, the heating element is parallel to the nozzle, which gives you better heat transfer. So this can pump out a lot more filament a lot faster than other printers that don't use this style hot end. Changing out the nozzle is very easy. You just take the silicone boot off right here. Then you need a 12mm wrench to hold the heating block, while you use a 7mm socket to remove the nozzle. You've got to have this done when it's heated up the temperature, so you got to be careful not to touch it except with the tools, but it's fairly simple once you get the hang of it. So overall, I am super happy with this printer. I think I have over 200 hours on it so far. I've only had one little problem with the drive on the extruder, and that was an easy fix, just tightening a screw back down. So overall, I am very impressed with this printer. I'm so happy I bought it, and it's definitely lived up to my expectations.